Here we see Fram frozen into the ice steadily, and it had a very strong hull, half-meter thick hull made of oak, and it was shaped so if the pressure was too high, the ship would pop up. Nansen and Johansen, they managed to ski to Franz Josef Land. Not many people have managed to do that the way they did it. And they built a little, I wouldn't say hut, but a hole in the ground where they spent the winter. And here is the place where they were. You see this log making a beam for the roof, and they had walrus skins to cover up, and then they were down by the rocks there. They were spending the whole winter. Not a very convenient winter, I can tell you. Here we see a cartoon with Nansen in a steamship to the left, and then you see André, the Swedish balloonist, André in a hydrogen balloon. André's idea was that it must be much easier to reach the North Pole through the air instead of through the ice. André had two assistants with him. One was a physicist, Niels Strindberg, who was responsible for the camera equipment they had. He also designed the camera, and it is the prototype for the camera we today know as the Hasselblad camera. This camera had exchangeable lenses, exchangeable cassettes for different types of film, glass plates, and all kind of gadgets that you find on a modern camera. Here you see the camera with two stereo arrangement. They could take stereo pictures or regular pictures. Here we see 1897, André take off in southerly wind. But unfortunately for him, it didn't last too long. So after 3 days, they had lost sufficient hydrogen, so they could not fly anymore. They had to make a landing on the ice. And from the landing spot, they reorganized their equipment, and they had a small boat on a sledge, and they filled the boat with what they needed the most, and they pushed through the pack ice heading southeast. But after 3 weeks, they realized they hadn't come very far because they were going against the drift. So then they changed direction, and they settled on the ice floe and just kept drifting with the ice floe. And here we can see the route. At the very top, they landed, and then they walked on ice, and then they drifted down to White Island. You can see to the right there. White Island is 98% covered by an ice cap, but there's a small beach where they made it ashore, but 2 weeks after, they were all dead. And there are many theories why they died. My theory is that they were just exhausted, wet, and they froze to death, because there's no way you can dry your clothes up there. And 33 years later, their camp was found by a Norwegian sealing ship. This year it was very little snow and ice in the Arctic, extremely little. That's why the ground was uncovered, and they saw the remains of the expedition. And they found the camera, they found all the exposed film, which they managed to develop. 33 years later, they found the diaries, and this was a worldwide sensation. Here we see the world's first aerial photograph of the Arctic ice, taken by Niels Strindberg from the balloon with a 15-degree angle downwards. It was published at a certain time the following: the Arctic Ocean is warming up, icebergs are growing scarcer, and in some places the seals are finding the water too hot. All point to a radical change in climate conditions and hitherto unheard of temperatures in the Arctic zone. Exploration expeditions report that scarcely any ice has been wet with as far north as 81 degrees, 29 minutes. Great masses of ice have been replaced by moraines of earth and stones, the report continued, while at many points well-known glaciers have entirely disappeared. And when do you think this was published? Michael, when do you think? 1822? Well, you're close. It's only one number wrong. 1922. US Weather Bureau. So the 20s and 30s were a very warm period. And I think I can explain why later on. Well, observations of the Arctic ice were of course done through airships, which started to fly to the North Pole in 1926 with Roald Amundsens in the airship Norge. And here we see 2 years later, airship Italia, which was an almost identical airship, captained by Umberto Nobile from Italy. And Italy, Umberto Nobile, he returned from the pole to Spitsbergen, but before he made it all the way, they crashed on the pack ice, and that's a story I can speak 2 hours about, but I won't. But here we see the other airship, Norge, just before takeoff, where he was the first to fly across the whole Arctic Ocean from Spitsbergen to Alaska. And here's a picture of the North Pole, the 12th of May, 1926, 4 o'clock in the morning approximately. I was there exactly 75 years later at the same time. Sir Hubert Wilkins and Ben Ailson, they flew an aircraft from Alaska over the Arctic to Spitsbergen in 1928. So that was the first airplane to fly from America to Europe over the Arctic. Well, in 2005, a New York Times reporter came to the North Pole on a Russian tourist icebreaker and reported that the ice at the North Pole had disappeared. And that hit the headlines of all the newspapers around the world. I'm sure you have seen it yourself. But we'll see how much truth it was. Well, Einar Petersen, an old close friend of mine, he was chief navigator of Scandinavian Airlines. And he was the person who developed the navigational equipment needed to navigate over the North Pole. You could not use a magnetic compass, and the GPS didn't exist and so on. So they had a special gyro that developed by Bendix Corporation, and then he used a periscope which would fix a star, and also a radio signal from a star they used as a reference when they flew over the North Pole. And Einar Petersen, he was very interested in observing the ice on all his flights. He flew more or less every week over the North Pole for 25 years. And here we see one picture from 1954. You have in May, which is early summer, the ice is breaking up. There are small leads and so on at the North Pole. Another picture from 1957, when the first Scandinavian airline flew to Japan over the North Pole. And he was the navigator on that flight. And here we see 1963, what the North Pole looked like in July. And also Ice Island T3. It is a piece of shelf ice from Ellesmere Island that broke off in the early 50s. And when that was discovered, the Americans set up a base on it. And this ice flow drifted around the Arctic for 25, 30 years. And they could map the Arctic Ocean and the bottom carefully sitting on the ice here. To the right, you can see a little piece of the runway they had on the ice floe, and you see some houses to the left there. I was fortunate enough to be invited to fly with the Americans to this base. So he was a DC-3, and we landed on the ice there, and we left the engines running. It was minus 35 degrees. The only problem was to keep my movie camera going with the batteries that didn't like the cold temperature. And here you see the base, all kinds of huts with measurement stations of all kinds. Well, in 1958, the American nuclear submarine Nautilus was the first to go over the Arctic, but under the ice. It didn't surface. A few months later, USS Skate, the second submarine, surfaced at the North Pole, and this is what it looked like. And then the next year, it made another trip to the North Pole, and there was not much ice, as you can see. And then there have been many more American submarines at the pole. This is Alfred McLaren, who was captain on this submarine. He's a good friend of mine. And it could be nice weather up there too. And here's an interesting meeting between two American nuclear submarines and one British that had a rendezvous at the North Pole. And there's some ice and some open water. The satellite observation of the Arctic ice pack started in November 1979. And it is a very good way of observing the Arctic ice, but it is important not to overinterpret what you see, because you see the ice extent in the Arctic Ocean, but you don't see the thickness of the ice or how old the ice is. There is a newer satellite since 3 years that can do that kind of job these days. And if I just pick by random, the first satellite image of the Arctic was November 1979 and November 2003, 24 years in between. It's hard to see that any ice has disappeared, as we read every day in the papers. If we take March 2003 and September 2003, we see a difference. And September is the month of the year with the least ice in the Arctic. And if you can read the numbers at the bottom, we have 15.5 million square kilometers of ice in March, which is usually the maximum month. And then in September, with minimum ice, we have 6.2 million square miles. So it's completely natural that 60–70% of all the Arctic ice melts every year. So when they report in September that the ice is melting rapidly in the Arctic, it's something normal. It happens every year. Then there was a lot of noise about the Arctic ice in 2007. It was less ice than ever, and that was the evidence of global warming, of course, and of the problems with CO2, etc. But what happened that year, which is not very much spoken about, is that there were very strong winds from upside the picture here, pressing the Arctic ice pack towards Greenland and Canada. Both winds and currents move the ice. So that ice you see on this picture is more or less twice as thick as the ice you see on the next picture, because the currents and the wind pressed it together. But that was hardly ever mentioned, only that there was less ice than ever. I would like to say it was more open water than before, but it was not less ice if you weighed it. But something happened between 2007 and 2008 that I will come back to. And we see there's a lot more ice in 2008. And in 2008, let's see now, 2007, and the Swedish icebreaker, non-nuclear icebreaker, Oden, went north of Greenland. It was chartered by the Danish to find out how far out the Greenland continental shelf stretched out, because this is becoming a hot political issue. So the Danes wanted to find that out with the help of this icebreaker. A good friend of mine is the captain of this icebreaker, and I was the only person meeting the ship coming to the pier in Longyearbyen, Svalbard, and I came on board, and I made an interview with the captain, Thomas Ornell, and he explained the problems they had to go through the ice north of Greenland because it was so compressed. And he had been to the North Pole, I think, 3 times with the icebreaker without any sweat at all. But he was sweating quite a bit, just barely making it through the ice back from Greenland. I had this interview on a video which I sent to the Swedish national TV, and they showed the film with the icebreaker coming in to Svalbard, to Longyearbyen, and so on, but they didn't show the piece when he's talking about all the ice causing a problem, because that year all the famous people went to Svalbard to see the ice disappear. So they didn't want any contradictory message here. Well, the next year, 2008, the German Alfred Wegener Institute, who owns this modified airplane, they have an ice radar fitted to the belly of the airplane, and they flew up and landed on Svalbard here, and then it continued up to the North Pole, where the Russians have an airstrip, actually for tourists. And then it flew over to Canada and around the Arctic and back again. And the results reported was that the ice thickness had increased 1 meter over the whole Arctic from 2007 to 2008. But have you read about that in the papers? No. Guess why? Also, the Alfred Wegener Institute is not very loud on this issue. I don't know if they were blackmailed by the politicians or something, but they are keeping very quiet about these results. Also, the American Army, for some reason, are measuring the ice thickness north of Alaska. And also during that year, the ice increased dramatically to 2009, as we can see here. So if we look at the 3 years, 7, 8, 9, we can see the ice is increasing. So 2007 was a kind of a minimum point. And then we have 2012, yes. This year it was not too much ice, and it was not blown and compressed like 2007. So there was less ice this year than it normally is. And the reason for that was El Niño last year. And why that El Niño melted the ice, I will come back to. But something else happened this year that was extraordinary. The right picture shows the ice conditions in October this year, very recent picture. And it shows that the ice doubled in 1 month. The amount of ice doubled in the Arctic, which has not happened before. If we go back to 2003, the increase from September to October was 20–30%, which is a normal figure. But this year, it's 100% more in 1 month. So nothing is normal anymore. And what controls the amount of ice in the Arctic? Well, it's ocean currents in the Pacific. It's called PDO, Pacific Decadal Oscillation. And this warm water flows through Bering Strait into the Arctic and drifts around, and some of it goes out between Greenland and Svalbard in the Fram Strait. This is Hadley Institute's global temperatures measured monthly and plotted in. And they claim that, well, here I wanted to show that since 79, when the satellites came up, we are in a warming period from 77. These two things coincided, the natural warming and the satellite measurements. So, but we only hear about the ice continuously melting, and they don't tell us what it was before 79 when the satellite started. And between 1940 and 77, we had a cooling period. I don't want to go too much into temperature measurements, but we had a cooling period. The temperature dropped 0.3 centigrades. And the climate experts, like Mr. Schneider and others, claimed that we were going into an ice age. And there were articles in Time magazine, The Big Freeze, How to Survive the Coming Ice Age, etc. But in 1977, something happened, and it got warmer again. And the same activists are now claiming that the Earth will burn up because of heating, etc. You know all that. Well, here you see another map showing the current coming in from the Pacific and all the different currents. The Gulf Stream coming up along the Scandinavian coast, going into Barents Sea, but it doesn't say very clearly how deep the current is. Nansen discovered already in 1912 there was a warm current past Svalbard at 300 meters depth. And Papanin in 1937, when he was sitting on an ice floe on the North Pole, he also sent down a thermometer and found warm water between 300 and 700 meters. So it is the Gulf Stream that doesn't stop or turn. It goes down and goes across the whole Arctic. And you don't have to worry about the Gulf Stream stopping. The reason we have the Gulf Stream is the rotation of Earth, and you have the Coriolis effect. So if you want to stop the Gulf Stream, you have to stop the Earth's rotation first. Good luck. Well, I mentioned the Pacific Decadal Oscillation. Well, if we look at this picture up here, the Pacific Decadal Oscillation is an horizon current that is positive going anti-clockwise and negative going in the other direction, clockwise. When it's going clockwise, warm water from the equator moves up along the American coast, Alaska, and into the Arctic here. And if it's negative, the cold water moves over here, and no warm water goes into the Arctic normally. And the intensity of this current varies, as you can see on this diagram. And then in 1940, it switched from positive, strong positive, to very strong negative. And then you have a cold period here, as you can see. And in 1977, it switched dramatically, and it's called the Great Pacific Climate Shift. And this is what controls the ice in the Arctic, if you didn't know it. Nome in the Bering Strait had a dramatic jump from 76 up here, and then slowly going down. So this is the warm water flowing through Bering Strait, a dramatic temperature effect along the Alaskan coast here. Well, we are told that the global warming is what you see on this diagram. The temperature goes like this, and then it decreases rapidly over here. And that's not how I view this diagram. I view it in the following manner. I see an increase for 30 years here. I see a decrease for 30 years to 1910, and then we have a dramatic increase for 30 years to 1940, a decrease to 77, an increase to 2008, and it's now turned. In April 2008, this current reversed suddenly, causing a lot of problems for the farmers in California. And above the curve, you see PDO was positive, PDO negative, PDO positive, negative, positive. So the reason we have a climate change going up and down like this is the ocean current going positive or negative. Around the coast of Svalbard, we can see that 2008 it was normalized, a lot more 2008, even more 2009 at the same January month. The measurement station on Svalbard is inside the airport area. You can see it here. And on this picture, you see it over here. Here's the station. And 54% of all temperature stations measuring global temperatures are inside airports, which gives an idea that we have a temperature increase called global warming. But there's another problem here. That is that Professor Humlum from Oslo University, he set up a measurement station 5 kilometers into the valley, and he compared the data between these two. And he found that when there was open water, like it is on this picture, it was 4 degrees warmer at the airport than 5 kilometers into the valley. But if the bay was covered with ice, which drifts in here or it freezes, there was the same temperature. So here we have an increased temperature of 4 degrees for no good reason. Also, we hear that the Arctic is warming up dramatically faster than the rest of the world. Well, here are temperature measurements from those Arctic stations not affected by the urban effect. And we see the PDO effect here. We see a little bend 1940 and a little bend around 1977, plus minus. So there is a little effect, but not dramatic, of course. Well, big surprise, what's happening in the Antarctic? Well, right now, there's more pack ice around the Antarctic than has ever been. Since measurements started, it's never been so much ice. And strangely enough, if you add the amount of pack ice in Antarctica and Arctica, the sum is constant, year by year. We don't know why, but it's a fact. It's the same amount of ice all the time. Well, I wanted to say a few words about glaciers, why they are melting and why. Well, glaciers started melting after the Little Ice Age in the 1600s. So we can see here in Alaska, Glacier Bay. This picture shows the ice extent, glacier extent, 1644, and 1821, 1852, 1895, and today up here. So it's an ongoing process since we left the Little Ice Age in the 1600s. Well, in Himalaya, we hear that the ice is disappearing. A friend of mine was there in Sikkim, 1972. This is the world's third highest mountain. And he took a picture of this glacier here. He was back 3 years ago, I think it was. I took a new picture from the same spot. You can hardly see any difference in the amount of ice here. Also, the Gangotri Glacier is pictured here in 2004 and 2008. And you can see the rocks still the same place. The glacier front has moved 1 or 2 meters. No dramatic change. Possible future ice conditions. Well, the solar physicist Habibullah Abdusamatov, he put this diagram together using all the different solar cycles that we know. And he discovered that the sum of all the solar cycles, they point down and are now down here to the same level as end of the 1600. It means we are now heading into a new Little Ice Age. We should worry about a new cold period with not so good crops and harvests as we are used to, causing famine and other disasters around the world. Here we can see what happened with the sunspot frequency. Here it dropped down dramatically. The sun was very quiet a few years ago, and this resulted in the combination of hardly any solar activity and the turn of the PDO caused the cold winters we had 2 years ago and 3 years ago, what we called war winters, the same as we had 40, 41, 41, 42. They came back. And they came back just after the switch of the PDO. The energy content in the oceans are now decreasing, like you can see on these diagrams here. And this is what they expected it to be, but in actuality it went down and is continuing down. And so here we can see what happens when we have a switch with PDO and the solar activity here being low. We had the war winters. Here we had the last winters, cold ones, no solar activity, the switch of PDO. Olof Erik Nordenskiöld, who I mentioned earlier, he was the first white man, so to say, to manage to do the Northeast Passage with his ship Vega in 78 and 79. And why did he make it through? Here we see him pass Cape Chelyuskin, and here he froze in just 1 day sailing from Bering Strait. So I'd spend the winter here, which annoyed the crew very much. And here you see where they wintered at Pitlikai, and here's the route. And why did he make it through? Well, your answer is here. We had a super El Nino, 77, 78, that reduced the ice that summer, compared to the Super El Nino we had in '98. This is a 1 in 100 year kind of thing here. So had he tried the year before or the year after, he would not have made it through so easily. So he was more lucky than he knew.